Hello and welcome to my shop. This is Jim Dedman, Sawlogs Plastic Hubs. Hope you enjoyed today's video. We'll be doing something interesting, so hang around, let's have fun. Good morning everybody, this is your old buddy Jim. We got a project that I want to kind of do a little overview on that you're going to be seeing in probably at least 2 videos today. I'm going to do a little background and then I'm going to show you what's in my hands. My good friend, viewer, and YouTube creator Vernon Patriot recently purchased a Lisle drill grinder, and he's got some videos. I'll put the link in the description. I'll probably maybe put the link to the videos in my work here. We'll see. So the bottom line is he bought the grinder and there was some missing pieces on it, and I agreed to help him out because his shop's not completely set up where he can run. So what's been the interesting part about this is Vernon got some information from Lisle. I don't know if you can see this. This one here's the one we've written on, and I'll kind of go through the details. This is the drawings we got from Lisle here. I don't know how well you're going to be able to see this on camera. This is one of the pieces we're making. This is the whole assembly, and then there's a shaft involved here. Problem with the drawings that we have here is the drawings was based, the machining for the piece was based on a casting. Well, obviously we're not going to have a casting to work with, so we're going to machine this out of solid material. Therein lied the next problem. How do we figure out what the part should be with casting? Well, I reached out to several folks. I didn't have Mr. Pete's email. Mr. Pete, he restored one of these. So I contacted Randy Richard, who I correspond with from time to time. And Randy was gracious enough to send me Mr. Pete's address. And I emailed Mr. Pete. Mr. Pete went out, measured it, measured all the dimensions. I sent him the copies of what we was dealing with, measured it off of his machine, and sent the numbers to me in email. So first of all, we're going to have to give some thanks here to Randy Richard, but a real shout out to Lisle Peterson, Mr. Pete, for measuring this and getting back to me with an email, because he's got a lot, he has a lot of subscribers, does a lot of stuff, and to take the time to measure this, send the stuff back to us, is really, really greatly appreciated. So I'm going to get ready and get started this morning on getting this stuff together. I got a little something I got to tidy up on my last project here, sitting here at the table, and we'll get the lathe ready and we'll start on the on this here part right here today. So hang with us and enjoy. Okay, let's try this one more time. I've got everything set up to face this morning. What we're going to do is turn this down to the dimension we need. We got several people's been involved in this project, as I mentioned earlier. One of them is a friend of mine here locally, engineer, tool designer, and I sent him the information, and he also done a CAD stretch. The thing of it is, this diameter is the only one that's big difference in it between what we've been able to calculate 2 or 3 different ways. So being as we've been able to get dimensions off an actual Lisle fixture from Mr. Pete, I think it behooves us to work with that number. So basically, we can be around, what I'm going to do is shoot for 2 inches. It's like it says, it's 292. So I'm going to go for about 2 inches around that, or 2 inches 100 thousandths. And we're going to turn this thing back approximately enough where if we have any failures and have to make another one, we will. And Bozo, this is a project that Bozo can really feast on here, and we need to be prepared to throw the old boy a bone. So I still have my aluminum insert in from Tom in there too. I just didn't clean it up. Being as this is such a long piece and I don't want to saw nothing off, I'm just going to face it off and I'm going to turn it back a couple of inches and we're going to work from that area. Because we only need to make one and I'm not a caster, I decided to make this out of billet. Because A, I don't have a foundry, and B, it would, without a pattern, it'd be difficult anyway. So, with that being said, now we got a nice clean face. We'll go down here about 2 inches and turn this OD down. That's what we're going. That way we'll have enough. If we need 2 of these, we will be good. The idea here is to get enough to make 2 of these in case I fail. Hopefully I won't need to make but one. Like I said, Bozo likes to strike. As Harold says, oh, Bozo, he's a persistent dude sometimes. And I may have to go back down to 360. I don't know what size this is. I'm just going to take a cut and we're just going to throw a caliper on it because this isn't got to be precise dimensions. This is going to be the outside of the fixture once it's completed. Basically, this is going to be the outside of the fixture. So also that puts me having a little 1/2 inch line. Where did I lay my calipers? I got them out this morning. Boy, I lay stuff down. I tell you, it's rough getting old sometimes. Alright, so we got a good ways to go. I'll bring you back when we get there. Okay, we're going to start over for the 3rd time. I thought when I made the first one here with this angle running in it that I had a problem with maybe this moved in the vise. Well, evidently it didn't, because here's the second one. When I got it done, I'm still way out of center and way out of parallel with this. So what I'm determining with these 2 parts is getting another setup started. I basically went back to the lathe and turned another blank. So what I'm going to do is actually make my 1 inch part. You know, get my flat, my 1 inch, and then put it back in the mill, and then do the drilling in the groove on the part, where I'm working off of 2 parallel sides. That way everything should be square. And we'll see if that solves the problem before we start the lathe. So I'm pretty sure that's what we're doing, is trying to mill around the groove. We're creating a parallelism issue. Well, let me turn you around. To combat the problem, what I'm going to do is basically mill this thing in a 1-inch circle flat. That way I'm going to flip it over and drill and re-mill the slots in it. And hopefully, that way I'll know I'm square before I get too further. Then I'll go back to the lathe and turn it down and put the step in it. It's the only way I know that I can fix the problem I'm creating. It's got to be something in misalignment setups. And I don't want to turn it that way, but I feel confident taking 20,000 passes, I can still machine this out in the lathe the way I want it to turn out. And still make a quality part. That's what my issue is going to be. So, this is what we're going to give it a whirl anyway. Alright. So, I don't know how it's going to turn out. Can't be no worse than what I've done. I'm not going to blame it on Bozo. I'm going to blame it on poor technique. You know, just bad order of operations. So, all over again. What I've done, you'll notice I think I've showed you here, we've milled the block down. So what we done is we milled this block down, we turned it, we milled it to basically 1 inch. What I'm doing now is I'm finding the center of the 1 inch. That's really, one thing I hate is when these things vibrate and shake like that, it's really hard to locate centers on these sometimes. And when it's like this, it can be a pain in the butt toothes. I'm going to go ahead and, I'm getting in too big a hurry for the camera, folks. Stop and start again. Okay, now I'm going to find center. Alright. And I'm just using inside the chuck jaws because I get a little bit more area to touch than I will the other way. So like there's a little something, piece of dirt or something right there. Let's make sure we don't touch on it. And I got a kick and get a half Y, and I should be on center. Right there. All right. What we're going to do is a little sanity check. We'll roll this over here towards the center of the part and see if that's going to be on center. Look, sort of make it, see if it passes the smell test. Okay. Now, what I'm going to do here is I'm going to go ahead and I'm going to find the center, and I'm going to actually literally find the center and set up and drill the first. I'm going to touch off while I got the probe in here. Instead of using a piece of paper or anything, and I'm going to touch off right here and find the edge and call that X0 and go in. I think this is 100 thousandths, best of my memory. Let me make sure I'm telling a straight story. Size this is 200 thousandths. Move herself in 100, and call that X0. Then we'll go into where we want to drill the very first hole at, and which should be, I figured I've done this several times, and basically it's like 4/69 from each edge. It really didn't give us the dimension on this, but the last one looks so good, so I'm going to go in basically the same dimension. This is one of the hidden ones on the part. And I think that 470 is a real good number to put the hole in it. Look, turned out real good as far as that blend did. Okay, so now I'll just pop the center in here and drill a hole. I've done a lot of soul searching. So after a little soul searching, I've decided that we're going to go ahead and do this. We'll make the shaft out of a bigger piece of material. Out of cold rolled steel to a little larger piece of steel. And we're going to go ahead and we're going to ream this thing a 1/2 inch. The reason being is I just wanted to noisy this morning. This little RPM up. The reason being is I wanted to be able to, so there is our, okay. So now this hole that I just turned is going to be this hole is going to be where the shaft itself presses into. So now let's get this figured out. Okay, now we're working on the slot. What I've done, let me move you back because you're right kind of in my way. I've already got it kind of figured out to put it where I want it. What we're doing is putting the slot in before we do anything else. And what I've done is, then I'm going to go back. I still got to make it the right width, but I'm using a carbide mill to mill it. And I've got basically milling the numbers here. And taking light cuts because obviously we're running a multi-flute carbide mill in aluminum. Not the best situation. So what we've done is, and we got to widen this thing out once we get to it. We're going to go get through it, obviously. We got to go all the way through it. It's basically 3/4 of an inch thick. See, this is what we're really doing here. Is basically, I'm doing all this, so what I'm going to do is we'll be back on the mill here before it's over with. Because I've got to get the shape, but to get the feature in it and get somewhat of a radius, I'm going to try something unusual, and that's the piece I'm not sure how it's going to work. So, and like I say, I'm just taking light cuts because of using a multi-flute carbide mill down in aluminum. I'm just taking something like light cuts and just keep passing through it. Try to get me the slot where we want it. I'm not trying to get greedy. We're just making one, folks. Hopefully we only make one. We don't have to remake one. That's the piece I'm trying to avoid here, is make more than one. Make one and have Bozo to visit, so. You know what I mean? We don't need no visiting Bozo the Clown. And he still ain't got through yet. So now I still got to widen this out. This is only a This is only a 3/8 end mill I'm using. I mean, this is not a 3/8. I mean, it's not the width it calls for. They call for a little odd width. The clearance is what they did. And my air compressor don't like cold weather. I really need to see down in there. So I'm going to get this thing through and I'll bring you back. Good morning. I will say happy birthday to me. Today is my birthday, by the way. We kept running into some issues, and I think you've seen this earlier in the video. And I'm just going to go back and rehash what the problems are. This is my third attempt on the lathe. And if you'll notice, this part looks a little different than what I've been doing. My first two attempts was centered around the idea that I wanted to leave a lot of material here and then mill the flats in later. What that's, and I explained that earlier. So now what I've done is actually I remade the part third time out of a piece of stock. And now I'm putting this radius in. Of course, there's still going to be the blends and stuff's got to be done, obviously. And there's probably a flat that has to come here and I'll put back in the mill. So I'm going to go back and turn, bring you back and turn a little bit more off. Get this down to size. And this still don't change, but what I have found, I've got an indicator set down here at the bottom, that you can't go but about 25 thousandths at a pass doing this. This interrupted cut is held on this small arbor, that the part will slip on this arbor very easily. So it's a very patient process. So one of the lessons, the takeaways of this, and I'm not going to use the typical Bozo visitor shop, just poor technique. And I mentioned this a little earlier. Getting the grooves, the slot parallel to the faces, just didn't, my machining method, and I'll actually show the last one in this series before I come to this, and it'll be in the video where the last one I tried to mill it by putting a parallel in the slot. This really didn't work. So basically now I'm just whittling this down to size, and once I get it down to size, I'll bring you back here in a little bit. Okay, we're going to do the last pass down the OD now. Down the face, and then we're going to come back and true this up a little bit. Now work down to a stop. Anyway, this is the last pass, and I've had no trouble with this operation every time I've done it. The problem has been other things. So, word to the wise, if you ever try an idea like I'm doing, make sure you have all your features in parallel. Probably the best way to do it is what I ended up doing, is basically turning the slug and then milling the slug to size, and then turning around and Well, I don't really care because I pull this off, go back down, touch, because this is, again, these are not critical sizes. So all I'm going to do now is just turn enough off to make this look good and blend it right up to the bottom. I have a little bit of a gouge on this one because I started cutting before I had it turned, but the gouge is going to be there because I don't feel like making nothing to get rid of the gouge. Now we're going to have some flats and ships, which is perfectly, there you go, that's looking good now. I have to turn this loose, put us a nice, get it up here, put us a nice big chamfer on there. And I'm going to take me a piece of sandpaper right here and just kind of blend this around a little bit to give me what I want. And so I'm going to leave that little gouge in it because it won't hurt nothing. I don't feel like making a new one to get rid of that gouge. And we'll take this out. And I'll bring it up to the camera so you can see it. Let me get it up here where I can show you. There's the... So this is how it's going to look. Now we'll have to do some other blending, and there's a little bit of milling that's still got to be done. So we'll get to that here in just a second. I hope you enjoyed the video. So let's put a disclaimer out of the way. This video is my idea how to do things. It's not the only way. So I hope you enjoyed it today. The other thing, comments are always welcome. Please take the time, if you feel so inclined, to make a comment on my videos. Also, I appreciate all my subscribers, the new ones and the new ones. And finally, the other disclaimer. This is a copyrighted production of James Dedman, Sawlogs Plastic Hubs, for your enjoyment on YouTube. Thank you. Have a great day, and we will see you in the next video.